Right now, more than 8 billion people are standing on the planet's surface. And if we all jumped up at exactly the same second, something would happen that most of us never think about. Something that sits at the intersection of physics, biology, and a question so simple that it sounds ridiculous, but it's not. In fact, this thought experiment reveals something genuinely surprising about how our planet actually works. If you enjoy learning how your body, mind, and world really work, the kind of knowledge that changes the way you see ordinary things, subscribe now, because this channel breaks down the complex stuff into ideas so clear, you'll wonder why nobody explained it this way before. Now, let's jump into this. The question seems obvious on the surface. You take 8 billion people, line them up across every continent, and at a coordinated moment, everyone leaps into the air. What happens? Most people guess one of two things. Either nothing happens at all, and the planet barely notices, or we all jump with enough force that we somehow alter Earth's motion through space. One of those guesses feels dramatic and impossible. The other feels disappointingly boring. But here's where it gets interesting. Both of those instincts are partially wrong, and the real answer is far more nuanced than either extreme. The truth is that something genuinely would happen, and to understand what, we need to talk about momentum, but not in the way you learned it in high school. Momentum isn't just about objects moving, it's about the universe's way of keeping track of motion. It's a universal rule so fundamental that it almost never breaks. When you jump, you're not just moving yourself. You're moving the entire planet in the opposite direction. You might think that's absurd. The planet is so massive and you are so small. The math says otherwise. Think about it this way. When you stand on the ground and jump, your feet push down with force. By Newton's third law, the Earth pushes back up on you. But here's the part people miss. While you're accelerating upward, the Earth is accelerating downward. It's so slight that we can't measure it with any instrument we've built. But it happens. The Earth moves. Now multiply that by 8 billion people jumping simultaneously, and suddenly we're not talking about an imperceptible shift anymore. Scientists have actually calculated this. If every human being on Earth coordinated a jump with equal force, the planet would move, not by kilometers, not even by meters, but it would shift. The displacement would be somewhere in the range of a few centimeters, about as much as your foot moves when you take a step. The planet itself would recoil. It sounds small, but conceptually, it's massive. We live on something so large and so apparently immobile that we've built our entire civilization assuming it never moves. And then a simple thought experiment reveals that yes, it does. We just haven't been coordinated enough to notice. But this is only half the story. The real question isn't whether the Earth moves. It's what happens to gravity when we do this. And this is where the psychology of the moment becomes crucial. Most people think gravity is constant, unchanging. But gravity is actually produced by mass. And when 8 billion people jump, they briefly leave the surface. For those few seconds of the jump, the distribution of mass on the planet changes. Nothing dramatic, nothing catastrophic, but real. When you're standing on the ground, you're being pulled down by the planet's gravity. You weigh exactly what you weigh. But when you jump, you're no longer in contact with the surface for that brief moment. Your weight hasn't changed, but you're no longer pressing down on the planet. So every human who jumps simultaneously is, for a fraction of a second, removing their mass's contribution to the pressure on Earth's crust. The planet's surface loses 8 billion people worth of weight at once. Here's where most people expect disaster. They imagine the oceans shifting, earthquakes triggered, some catastrophic cascade. In reality, the effect on gravitational fields would be infinitesimal. The change in Earth's gravitational pull during those seconds would be absolutely undetectable. We're talking about forces so small that they're hundreds of times weaker than the gravitational effects caused by the moon. And the moon orbits us without tearing the planet apart. But that doesn't mean nothing happens. The actual physical consequence is subtler and, in its own way, more fascinating. When everyone lands, the impact changes things. All 8 billion people hit the ground nearly simultaneously. That's 8 billion impact events happening in a fraction of a second. The energy involved is staggering. It's roughly equivalent to dozens of large bombs detonating across the entire planet at once. The seismic waves generated would ripple across the Earth's crust. In areas with sensitive monitoring equipment, seismographs would register it. It wouldn't trigger earthquakes in the traditional sense. It wouldn't shake buildings or cause damage, but the ground would move. The planet would vibrate. We would have created a global pulse, and that detail changes everything about how we think about this scenario. Because we're no longer talking about physics as an abstract concept. We're talking about a moment where 8 billion individual actions create a synchronized effect so powerful that it generates planetary scale consequences. This is where the psychology of coordination intersects with physics. Every person jumping alone creates an imperceptible effect, but everyone jumping together creates something measurable. It's a reminder that there are certain types of power that only emerge through perfect synchronization. But let's dig deeper into the actual mechanics of what your body does when you jump. Because that's where the real insight hides. When you jump, your muscles release energy stored in your cells. Mitochondria convert glucose into ATP. Myosin proteins pull actin filaments. Fibers contract. It's a cascade of biochemistry that happens so fast and so automatically that you never think about it. But when you multiply that process across 8 billion brains, all sending the same neural command at the same moment, you're orchestrating one of the largest synchronized muscular contractions in human history. Every jumping human generates roughly the same amount of force, around 3,000 newtons. That's the equivalent of a person jumping about half a meter into the air. Now multiply that by 8 billion, and you're talking about roughly 24 quadrillion newtons of force directed downward, all at once. To put that in perspective, that's more force than is released by a magnitude 5 earthquake. It's a global muscular contraction so coordinated and so vast that it rivals natural disasters in its energy output. But instead of tearing the Earth apart, we've just created one synchronized pulse, one moment of planetary communication made entirely of human muscle. Here's what most people get wrong about this scenario. They assume that such a massive force should produce massive consequences, that intuition is so strong that it overrides the physics. But Earth's crust is remarkably resilient. It's designed by hundreds of millions of years of evolution and plate tectonics to handle stresses far beyond this. Earthquakes release orders of magnitude more energy. Volcanic eruptions dwarf it completely. The impact of the 8 billion jump lands somewhere between a heavy rainstorm and a modest seismic event, measurable, real, but well within the range of what the planet handles routinely. Yet there's a psychological shift that happens when you truly understand this. Once you know that 8 billion coordinated humans can create a detectable planetary vibration, the world starts to feel different. You start to realize that the Earth isn't inert. It's not immobile. It's responsive. It reacts to us, not easily and not catastrophically, but measurably. And that changes something fundamental about how you conceptualize human beings in relation to our planet. We're not passengers on something fixed. We're participants in something dynamic. But the thought experiment doesn't end with physics. There's another angle that reveals something unexpected about human nature itself. To successfully coordinate 8 billion people to jump at the same time, we would need something that humans have struggled with throughout history. Perfect synchronization across all cultures, languages, time zones, and beliefs. We would need to overcome the basic reality that the world is divided by geography, time, and incompatible interests, and that's genuinely difficult. There are only a few moments in human history where billions of people have synchronized their attention simultaneously. The moon landing in 1969 reached an estimated television audience of 600 million people. The 9/11 attacks synchronized global awareness. Major sporting events like the World Cup reach about 3 billion viewers, but none of these achieved true global simultaneity. There's always a delay, always a subset of the world that doesn't participate. To actually coordinate 8 billion people to jump at the exact same moment would require infrastructure that doesn't exist. Communication systems that cover every village in every remote location, a shared motivation so powerful that it transcends all cultural divisions. And that, in itself, is an interesting thought experiment. What would it take for humanity to coordinate at that level? The deeper consequence isn't physical, it's psychological. The fact that we're even capable of imagining this coordination reveals something about how we see ourselves. We imagine global unity. We imagine synchronization. We imagine becoming one thing, momentarily, with shared purpose. And that collective daydream is revealing. It suggests that somewhere deep in the human mind, there's a desire for connection on a scale that transcends our actual ability to achieve it. We're fascinated by moments where billions of individual actions create one unified outcome, perhaps because such moments are so rare in actual experience. Now, there's one more layer to explore, because the question of what happens if everyone jumps isn't really a physics question at all, not fundamentally. It's a question about scale and perspective. It's asking, at what point do individual actions become significant? At what point does the negligible become measurable? And the answer is, it depends on how many people you have. One person jumping does nothing. 1,000 people jumping barely registers. 1 million creates a slight tremor that instruments might detect. 1 billion people jumping generates seismic waves that circle the planet. But 8 billion people, they create something that matters. They create an actual event. This is why the question is so psychologically potent. It sits at the intersection of nihilism and agency. You could look at yourself and think, I am insignificant. My actions barely matter. The planet doesn't even notice when I jump. And all of that is true. But the same physics that makes individual action negligible also tells us that if enough of us act in concert, we become significant. We become measurable. We become consequential. We move mountains. Well, we don't move mountains, but we move the planet itself. And that's a thought that lingers, because in a world of 8 billion people, most of us feel small. We feel like our individual actions don't matter. The problems we face seem too large. The planet seems too vast. But this thought experiment proves something. Given the right coordination, given the right moment, 8 billion small actions create something undeniably real, something that registers on instruments, something that the planet responds to. The question of what happens if everyone jumps at the same time doesn't ultimately have an answer about physics. It has an answer about perspective. It reminds us that we're not separate from the planet. We're part of it. We're part of something so large that our individual significance seems negligible. But when you multiply that insignificance by billions, becomes significance. The negligible becomes measurable. The impossible becomes inevitable. And that maybe is the real mystery. Not what would happen to the Earth if we all jumped, but what would happen to us if we truly understood how connected we are. If we grasped, not just intellectually, but viscerally, that our individual actions matter less than we think, but our collective actions matter far more than we assume, that we are 8 billion individual forces that, when perfectly aligned, can alter the planet itself. The question isn't whether the Earth would move. It's whether understanding this would move us.